Okay, ladies, welcome to the video for the product and quotient rules of differentiation. We're going to begin with the product rule now. And what the product rule is about is, let's suppose you have a function, okay, we'll call it y equals f of x times g of x, where both f and g are differentiable functions in and of themselves, but you're multiplying them together, f of x times g of x. Well, the way you would take the derivative of this is a little different than a sum or a difference. Okay? Remember, when you add two functions, you just take the derivatives separately and add them up or subtract them up. For multiplication and division, for that matter, it's going to be a little bit different, a little more complicated, but I know you can handle it. Okay? Here's what we do. So the derivative with respect to x of the product f of x, g of x is going to equal f of x times g prime of x plus g of x times f prime of x. So in other words, we just take the first function times the derivative of the second, and then we add to that the second function times the derivative of the first function. Okay? We'll do that with an example. So, let's do the derivative of h of x equals 3x minus 2x squared times 5 plus 4x. Now, could you FOIL this out and just use the power rule? Sure. But really, the reason why the product rule comes about is these two functions later on in the year are going to be more complicated. They might have trig values in them. They might have exponential functions in them. They might have natural logs. So it's important to understand this rule for maybe more basic examples like this. So when we get to more complicated examples later on in the course, it can all fall in line for you. So the derivative of h is going to be the first function times the derivative with respect to x of the second function plus the second function times the derivative of the first. I'm running out of room there, but I think you understand the idea. So, we get 3x minus 2x squared times the derivative of 5 plus 4x, which is just 4, plus the 5 plus 4x times the derivative of the second function, which will be 3 minus 4x. Okay? And then from here, it's just some algebra. We can multiply the first two together, and I get 12x minus 8x squared. We can FOIL this part out, and we get 15 minus 20x plus 12x minus 16x squared. Why don't I simplify that part before I combine with the left product? So I get negative 16x squared minus 8x plus 15. And then we can combine like terms. I get negative 16x squared. Oops, excuse me, that should be an 8x squared there, so that's wrong. It should be negative 24x squared plus 4x plus 15. So that would be the derivative of this h of x. Okay? Let's do one more. Okay, let's do g of x equals 6x plus 5 times x cubed minus 2. Okay, so we'll go a little bit faster with the rule. So it's going to be the first, which is 6x plus 5, times the derivative of the second, which will be 3x squared, plus the second, x cubed minus 2, times the derivative of the first, which is 6. All right, we'll distribute. I get 18x cubed plus 15x squared plus 6x cubed minus 12, and then we can combine our like terms. We get 24x cubed plus 15x squared minus 12. Okay? Now, by the way, if you FOILed g of x to begin with, you would get 6x to the fourth plus 5x cubed minus 12x minus 10. And if you use the power rule for this, don't you get the same thing? 24x cubed plus 15x squared minus 12. Okay? So that's a way you can check if you're doing the product rule correctly. All right, now let's look at the quotient rule, a little bit pickier. Okay, so suppose we have a function y equals, and it's a quotient. We take f of x divided by g of x, where f and g are both differentiable, and g of x is not going to be 0. How we get dy over dx is we're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom function squared. Okay? Here's another way we can do this. All right, there's a chant that I've learned to remember this. I go low d high minus high d low, square the bottom, and away you go. And by d, I mean derivative. So low, g, times the derivative of the high, f of x, minus the high, f of x, times the derivative of the low, g prime x, all over the bottom squared, gx squared, okay? So that's the quotient rule. There's where it is in your book. The top one, the bottom one is my chant. I'll say it one more time. Low d high minus high d low, square the bottom, and away you go. All right? Let's look at an example of that. Okay, so let's do y equals 5x minus 2 over x squared plus 1. Okay, so I want to take the derivative of this. That's going to be the bottom, which is x squared plus 1, times the derivative of the top, so 5x minus 2 prime, minus the top. Well, you know what, let's do this down the bottom because I'm running out of room. X squared plus 1, bottom, derivative of the top, minus the top, derivative of the bottom, all over the bottom squared. Okay. Order is very important here because of subtraction, so please make sure you follow what's in the chant and what's in the rule. So we do the derivative of 5x minus 2, that's just 5. So we get 5 times the quantity x squared plus 1. The derivative of x squared plus 1 is 2x. And we multiply that by the 5x minus 2. And we get x squared plus 1 quantity squared. Okay, and then you can work through the algebra, but since I'm running low on space, I'm going to give you the answer. I get negative 5x squared plus 4x plus 5, should be a plus sign, excuse me, all over x squared plus 1 squared. Okay, sorry, my iPad's not really working well for some reason today, so that's why this is a little bit messy. But I'll repeat it verbally. I got negative 5x squared plus 4x plus 5 all over the quantity x squared plus 1 squared. Okay, I just want to do one more, and that should be enough to give you the opportunity to do some practicing with this. All right, let's do g of t equals t squared plus 2 all over 2t minus 7. All right, so I'll do this one a little bit quicker using the chant. Okay, so we do low, which is 2t minus 7, d high, which is 2t, minus high, which is t squared plus 2, d low, which is just 2, square the bottom, 2t minus 7, and away we go. Now we just have to clean up the top. So I get 4t squared minus 14t, and then I get minus 2t squared minus 4, because I distribute the 2 in, but then I also have to distribute the negative sign in, all over 2t minus 7 squared. That gets me 2t squared minus 14t minus 4, all over 2t minus 7 squared. That is g prime, the derivative of g, with respect to t. Okay? We're going to do a lot more practice with the product and quotient rules, but this should be enough to at least sink your teeth into some practice with this. All right? If you have any questions, please be sure to ask me. These are 2 rules that you really have to have memorized, because whether you're in AP Calc or Honors Calc, it's going to come up a lot, and we need to make sure that we understand it. All right? Thank you very much for watching.